at the start of a lecture, normally, right? Normally, I would always kind of start with just some thoughts, big picture thoughts. What's going on? How's the semester? What's the weather like? What'd you do this weekend? Just get to know each other because we're people. We're engineers, but we're also people. This semester, since they're all pre-recorded, there's not a chance to just kind of talk, right? We don't get to talk. You don't get to sit there and say, hey, Dress, what about this? Or, hey, yeah, I did this. Or we saw this in the dorms. I like that stuff, right? That's one of the most fun parts of teaching is getting to know you guys as people and helping you to grow as engineers. So I thought, you know what? It's trying times. I'm going to take a few minutes and just kind of talk about my observations and what I see. As you can see, this is not my office at school. I wish I had an office like this at school, but I don't. I'm still wearing my pajamas. So first of all, I hope you're well. I know that many of you have contracted this little this pesky little COVID-19. I hope you're faring all right. I really do. I've talked to many of you, and you seem to be doing fine, other than being stuck in a hotel room somewhere. But I really hope you're well. Number two, some of the best friends, in fact, arguably my best friend in the world, who will be one of your guest speakers or guest video recorders later this semester, is a guy that I lived with in the dorms my freshman year. And this is not exactly the college experience that you might have thought you're going to get or that you envisioned a couple years ago, even 8 months ago. But the dorms are a ton of fun, right? It's fun to move out of the dorms and get your own apartment at some point, but you are right now trapped with some people who will be friends for the rest of your life. They will go on crazy adventures with you. They'll do stupid stuff with you. They'll stand up your wedding. They'll be uncle and aunt to your kids. So enjoy this time. It's a little weird, but please do enjoy the time. The next few weeks, for that matter, next week is a little uncertain. Nobody really knows where we're going to be, where you're going to be. Are we going to get to go into the lab and do some stuff, or do you have to do stuff at home in your dorm room? I don't know what's going to happen. So please be flexible with us and keep up the good work. It's been awesome. For my lab section, you guys you had the option of sitting in your dorm room and playing with Arduinos, but a bunch of you kind of rallied and said, hey, let's meet at the picnic tables outside the dorms. And we had a great lab section. So I hope you guys can do that. Figure out ways to work together, learn from each other, and enjoy this class. It was awesome to see a couple of the lab sections do it, and I hope you guys can keep that up. The whole point, so now the tangents begin, right? There's two main purposes of this class. In my mind, number one is to build a sense of community. You're at a school with 40,000 undergraduate students, right? And it's really easy to get lost, and you're just this one little person drifting around in this sea of academia. What I want to do is make the lab, make the mechanical engineering department, your class within the mechanical engineering department, and even then your lab section, a community, right? So you've got a community of 8, you've got a community of 20, you've got a community of 100 on your dorm floor or a couple floors, and you've got a community of the mechanical engineering department, which is 800 kids. So I want the lab, like our lab, 2158 ME. Some of you, sections 305, 6, 7, and 8, haven't even been in the lab yet. and I hope you get to make it, or at least to stop by and visit or something. I don't know. We'll see what happens. But in past semesters, the lab is a cool place to hang out, right? We're going to meet your friends. We're going to hang out in the lab, right? I think that's awesome. And so I want to build a community. Secondly, the point of this class is to prepare you to be good mechanical engineering students. And to do that, we need to teach you some of the tools you'll need to be good mechanical engineering students. And to do that, we go through this design, build, test process. So what does it take to design something? Really a lot of computer tools. You need to have the math and the physics background, which you're building now. And then you have to have some computer tools so that you can kind of design it ahead of time and make sure everything fits together ahead of time, right? With assemblies and drawings and dimensions and this kind of stuff. And you'll have classes where you learn the math, right? And you'll have classes where you learn SolidWorks much more than we do in this class. And you'll have classes where you develop these design tools. Then you have to build it, right? The academic side of it is you guys will probably take ME 310 and 311, which are the new design classes where you learn how to make stuff out of plastic, you learn how to make stuff out of metal with different techniques, right? ME 310. Currently it's 313 and 314, but we're changing it to 310 and 311. So you learn how to build this stuff. But as freshmen in this class, we want to build it in the lab. Do we have access to that, right? Hopefully we come back and you've got access to a machine shop with mills and lathes. You've got access to a makerspace with laser cutters and water jets and CNC lathes and 3D printers. And so we could build some pretty cool stuff. Alternatively, what may realistically happen is that you have to go home and make this with a hand drill, some wrenches and screwdrivers, and whatever you can scrounge up at your local hardware store. And that's a real possibility. I've got a video clip that I'll put after this along the page about it. There is something fun and there's great value in learning to say, well, I've got a hand drill, I've got some screwdriver, a few wrenches in the hardware store. How can I build this thing? And so we can have fun doing that too. I don't know which direction we're going to go. It's a little scary because this starts in a week. I still don't know what direction we're going. But as we talked, that's engineering, right? And we just have to be flexible. And then finally, after we design this thing and we build this thing, we have to test this thing. And testing means a number of things. First of all, say, does it work? Does the light bulb turn on, or does the motor spin, or whatever? It also means how well does it work? Is it generating as much power as I thought it would? Is it providing enough protection as I thought it would? Is it holding the loads that it's supposed to hold? And so we have to test these things. Testing, the nature of testing, certainly as engineers go, garage tinkerers can just say it works or it doesn't work. Engineers need to be a little bit more meticulous about it, make some measurements. These measurements require some oftentimes sophisticated instruments, tools, measurement tools, beyond just a ruler and a scale. Well, even a scale now. Show me, when's the last time you stepped on a scale and it didn't give you a digital readout, right? So these measurements we make often rely on electronics and electricity, resolution, data, analog signals. We're going to do that this week. So you'll learn a lot about these kind of measurements, primarily in a class ME 368, engineering measurements, right? It's just called engineering measurements. But we're going to kind of preview some of that today. Depending on how the class goes, depending on what happens with campus this semester, the emphasis might go from the build to more of designing and testing. And when we test this stuff, you might have to learn how to build these instruments yourself. And that means you've got your Arduino, you've got your breadboard, you've got some basic stuff that came with a kit. We'll figure out how to get you the other stuff you need so that you can do some more sophisticated measurements, learn how these measurements work behind the scene. There's no such thing as an accelerometer, right? What actually is an accelerometer? It's a bunch of other stuff that measures a bunch of other stuff that correlates that to an acceleration, and then finally you can convert that to some acceleration. The last thing you have to do in the testing process is break your thing, right? Almost regardless of what it is or what its function is supposed to be, you can't design things for being used. You have to design them for being misused. And so you need to know when it breaks. If you're designing diving boards, right? Sure, you say, well, it's a diving board. The average diver weighs, 180 pounds, and they go stand on it and they jump up and down, and eventually, it should be strong enough. But what you don't plan on is a bunch of dumb college kids saying, hey, let's see how many people we can put on the diving board at once, right? Now, this is dumb, right? But people do dumb things, so you have to know when this thing is going to break, right? Whether it's a diving board or a motor or a seatbelt or a rocket or a hammock or a globe or a Volkswagen van, microscope. I don't know how you can really abuse a microscope, so maybe that doesn't break. But you have to know when it breaks, and we are going to build something that we're then going to break. And it's hard to do because you put all this time and effort into building this beautiful prototype, and you say, well, now I got to break it. But you have to break it. So design, build, test, break. We're going to try to get all those things done. It'll be one route or another, either in the lab or at home or in your parents' basement or in the dorms or whatever. I don't know what's going to happen. We're going to kind of push forward the design tools a little bit compared to what we would have done in a normal semester. And then we're going to start, we're going to send you home or into your dorm room or wherever, or in the lab, or we're going to work on getting the Arduino stuff figured out a little bit more elaborate, complicated, but fun stuff to do with the Arduinos that are involved with the testing side of our things. And then hopefully we get to build, and hopefully we get to break. Be flexible, have fun, and focus on learning as much as you can in class and outside of class. And watch the YouTube video that I have right after this, and we'll see you soon. There will be lectures on some basic electronic circuits, and then a short demonstration introduction to engineering equation solver coming very shortly. So thanks for watching this. Watch the YouTube video about Apollo 13, and then some circuits and engineering equation solver coming up. I'll talk to you soon.